Hey everyone, this is Algebra 1, Unit 7. This is the practice test, and so I'm just going to go through and work the problems on the practice test to give you an idea how to do these, okay? So the first problem here, this is asking you to solve this equation. So it says use the graph to solve this, and so we're looking for the solution. Solutions are x-intercepts. It's where the y value is equal to 0, right? Where the y value is equal to 0. So who's going to represent the x-intercept? So I can just simply look at the graph here, and I can see that there is an x-intercept here when x is equal to 0 and when x is equal to 2. And so those would be my two solutions, 0 and 2. This question here is asking you to solve and find out where that function is equal to -1. Okay, so if you look down here, they're looking for the x value, and then this represents the y value. So what they're looking for, where the y value is equal to -1. So if I come down here to -1 on the y-axis, and I come over here, right, I can see that that's where that graph hits that point where y is equal to -1, and the x value there is -5. And so they want to know the x value that makes the y value -1. That's going to be -5. Similar problem here. They want to use the graph to solve the equation k of x is equal to 12. So k of x, that's the y value. They want to know where the y value is equal to 12. And so if I follow along the y-axis, I come up here to 12. I see that that graph does not pass through, right, where y is equal to 12. There is no value on that graph where y is equal to 12. So in this case, there are no solutions, and so I'd enter D not E for does not exist. Okay, so now they're going to get into some of the factoring stuff. Make this a little bit bigger. Okay, so when we go to factor this, this is problem number 4. So they give us 5x to the 5th plus 25x to the 3rd plus 35x squared. Okay, now when I'm looking at the greatest common factor, the way that I approach these problems is I look, first of all, look at the coefficients. Okay, so I have 5, 25, and 35. Look for the smallest number. The smallest number is 5. And then just check, does 5 go into 25? Yes. Does 5 go into 35? Yes. 5 is my greatest common factor for the numbers. And then I want to look at the degree of each one of these exponents. Okay, each one of these terms has an x in it, has a variable in it. The smallest number is 2. Okay, so the most number of x's that I could factor out of this would be 2. So this is going to be x to the 2nd power. And then I have to write down, what gets multiplied by that, right? What's left over when I factor that out. So here I have 5x to the 2nd power. I need 5x to the 5th power, so I need x to the 3rd power right there. Here I've got 5. I need 25, so I need to multiply that by 5. Here I've got x squared. I need to get x cubed, so I need to multiply one more x there. And then 5 times 7 gives me 35, and here I've got x squared. I've already got an x squared, so I don't need any more x's, so this would be my answer. Okay, so they're asking you to factor this, so I'm going to put the whole thing in. So this is 5x to the 2nd power times x to the 3rd power plus 5x plus 7. Double check that we got all that right. Looks good. Okay, question number 5, they're asking you to factor that completely. So I want to look for, first of all, a greatest common factor. So I got 56 y to the 8th minus 48 y to the 5th. And so there's only 2 terms in this. So I want to take a look and see what can I do there. So what do I have? The smallest number is 48, but 48 doesn't go into 56. So I have to look at the factors of 48. And so 6 and 8 are factors of 48, and 8 is a factor of 56. And so I believe that's the biggest one. Okay, if I look for the next biggest factor would be 16. 16 does not go into 56. So I think an 8 is what's going to factor out here. Okay, and then the smallest degree here is y to the 5th power. So I can take y to the 5th out of this, and there's y to the 5th in this as well. So I can take out y to the 5th, and then what do I have left over? 8 times 7 is 56, and y to the 5th times y cubed is y to the 8th. And then I've got a negative here, so we've got a negative, and then 8 times 6 is 48, and then I've already got a y to the 5th there, so I think that's done. Now, I would want to check and see if I could factor this any further, and this is not a quadratic, right? And so we wouldn't really try to factor that at this point. Okay, so I'll put in my answer here. It's going to be go. So we've got 8y, I want to make sure I'm using the right variable, y to the 5th, times 7y to the 3rd power minus 6. Just double check that. 8 times 7 is 56, 6 times 8 is 48. I think we're good. Okay, number 6, they're asking us for the same thing. We're asked to factor that completely. So as I'm writing this down, right, I'm thinking through, like, what are the factors here? I've got w to the 14th, I've got 48, w to the 9th minus 6, w to the 6th, okay? And I'm going to start, again, looking at my smallest number, and so I've got 6 here. And does 6 go into 48? Yes. Does 6 go into 30? Yes. So 6 is going to be the number that I can take out. Okay, the coefficient I can take out. And then they all have a w, and the smallest degree is w to the 6th. So w to the 6th is what I'll take out there. And so look at what's left over. 6 times 5 is 30. W to the 6th, we need, I think, 8 more. W to the 8th. And then we've got 6 times 8 is 48. And we've got w to the 6th. We need w to the 9th, so we need to have 3 more w's. And then I've got 6, and I've got a negative here, right? And so 6 goes into that once, and I've already got w to the 6th, so I don't need to do that anymore. Okay, so there would be my factorization of that. Oops. Okay, so we've got 6w to the 6th power, and then times 5w to the 8th power, plus 8w to the 3rd power, minus 1. Double check. I'm using the right variable. Check my multiplication. I think we're good. Question number 7. So this is asking us to factor this completely. And I look at this, I see I've got a quadratic trinomial. Okay, quadratic trinomial. And they're using y's instead of x's, but that's okay. Quadratic trinomial, I'm going to try. Right? When I have these quadratics, I'm going to try to factor them into something like that. And so I need to look at the factors of y squared. Okay? We have a 1 as the coefficient there, so it's just going to be y and y. It's just going to be y and y. And then for these numbers, I need to find the factors of -8, right? The factors of -8 that multiply to give me -8 and that add up to give me -2. So I'm just going to write down the factors of 8. So I have 1 and 8. 2 and 4, and that's it. And I need to get a -8, so I know that one of these numbers has to be negative, and they have to add up to -2. So I'm going to look for a difference here, and so I'm going to use 2 and 4. So 2 and 4. And then, since this middle term is negative, right, that means when I add them together, I have to get a negative number. So that means my 4 has to be negative, and my y plus 2, right, that 2 is going to be positive. Okay, and I just want to kind of mentally check this. So this is y squared. The outside here is negative 4y plus 2y. That gives me negative 2y. And then the last terms there, 2 times negative 4 gives me negative 8. Y plus 2. Y minus 4. Okay, again, I want to make sure I'm using the correct syntax, make sure there's no error messages over here. And so I think we're good. Number 8, do the same thing. Trying to factor that completely. So as I'm writing this out, right, I'm thinking about the factors of 28 that add up to negative 11. Okay, now this 28 here is positive. That means when I multiply two numbers together, they have to be the same sign. Okay, they both have to be positive, or they both have to be negative. Since this middle number is negative, when I add those together to get a negative, that tells me that both of these factors here have to be negative numbers. So I'm looking for the factors of 28, the negative factors of 28, right, that add up to give me 11. And so, if I don't immediately see it, I can just start writing them down. 2 and 14, 3 doesn't go into that, 4 and 7 do, and I think that's it. And so I'm looking for ones that add up to give me negative 11, so that's going to be 4 and 7. So I'm going to have x, and both of these have to be negative, right, in order for that middle term to be negative and that last term to be positive. X minus 4, x minus 7. And, the order that I write these doesn't matter. I could write x minus 7 first and x minus 4 next. So, x minus 4, x minus 7. Okay, and if I just double check these here, this is going to be negative 4x, this is going to be negative 7x. Add those together, I'll get negative 11x. Negative 4 times negative 7 gives me positive 28. So number 9, x squared minus 3x minus 10. So I'm looking for the factors of 10 that I can make a 3 out of. My 10 here is negative, so that tells me that one has to be positive and one has to be negative. So I'm looking for the factors of 10 that have a difference of 3. And so down 1 and 10, 2 and 5. Looks like that's it. I'm looking for a difference of 3. So 2 and 5 give me that. So I get x here, 2 and 5 here. This middle number is negative. That means that my 5 has to be negative. So when I add those together, that bigger number has to be negative. And so I'll just do a quick mental check here. So 2 times x is 2x, times negative 5 would be negative 5x. So it's going to be negative 3, and 2 times negative 5 gives me negative 10. X plus 2, x minus 5. Okay, number 10, multiple choice there. We're looking for the factors of 56, right? And we're trying to make a 1. Okay, so we've got x squared minus x, that's minus 1x, minus 56. So I'm looking for the factors of 56. And again, I'm looking for a positive number and a negative number, right? So I'm looking for numbers that have a difference of 1, right? And so, again, I can write these out, 1 and 56. If you see it, there's no need to do that, but 2 and 28, 3 does not go into that. 4 goes into that 14 times, 5, 6, 7 times 8. Okay, so it looks like 7 and 8 will be our answers here. So we're going to have x and x. We'll have 7 and 8. This middle number is negative, so my bigger number has to be negative. Okay, so that's got to be positive. So x plus 7, x minus 8. So that looks like the last one here. So that. Go to the other side here. And so we'll look at problem number 11. Same kind of deal, y squared plus 14y plus 40. And I'm looking to factor that. So I'm looking for the factors of 40 that add up to 14. So everything's positive, so I'm going to have all positive numbers. So I can see pretty easily that 10 and 4, right, give me 14. So I get y plus 4 and y plus 10. And again, if you didn't see that automatically, you can just go and list out all the factors of 40, 1 and 40, 2 and 20, 4 and 10, 5 and 8, and see which one works. So y plus 4, oops, plus 4, y plus 10. The right variable, I think that works. Okay, so now they're asking you to solve this equation, right? So number 12, now they're asking you to solve it. So we're looking for the values of x that when I plug that in would give me 0 for an answer. So the first thing I'm going to do is I'm just going to write it out and I'll factor it. Okay, so if I look to rewrite this left-hand side in factored form, I'm looking for the factors of 35 that have a difference of positive 2. And so I have x and x. I think it's going to be 5 and 7. And since that middle number is positive, my bigger number here has to be positive. Okay, so there's my factorization. Now, I'm going to use what's called the zero property product, right? The zero product property. And that just says that if two things multiply, right, here I've got two polynomials that are multiplying to give me 0, that means that one of them has to be 0. So x plus 7 could be 0, or x minus 5 could be 0. And so what would make x plus 7 0? Well, negative 7 would make that 0. And what would make x minus 5 0? Well, x would have to equal 5 there. Okay, so my two solutions are x are going to be 5 or negative 7. And, I could check that. I could verify that in a number of ways. One, I could just simply plug those values in and, calculate those values. The other thing I could do is I could graph that, right? And I should see x-intercepts at x equals 5 and x equals negative 7. Okay? I could also put that into a graphing calculator, generate a table of values, and just check to see when x is 5 and when x is negative 7, my y value should be 0. So there's a number of ways of checking those. Let's put our answers in here. We got a 5 and negative 7. Number 13. Okay, so number 13, they are giving us an equation here. Right? They're giving us a situation. So we've got this equation that tells me what the height of a ball is after a certain amount of time. So negative 16t squared plus 96t plus 112. Okay, so a couple of things to kind of take a look at here, right? Notice a person is standing close to the edge on the top of a 112-foot building. So if I were to draw this, right, I'd have a building here, okay? This height here would be 112 feet, okay? And I've got a person standing near the top of it, or at the top of it, near the edge of it. They throw a ball up into the air, okay? The ball goes up into the air, and then time goes by, and it comes down. Okay, and then here's the ground. They're looking for this point right here where it hits the ground. Okay, so they're looking for the amount of time that goes by before it hits the ground. Okay, so at where it hits the ground there, my height is going to be 0. So really what they're asking me to do is to solve this equation. Negative 16t squared plus 96t plus 112 is equal to 0. Okay, that's the equation that I'm being asked to solve here. All right, and they want to know two things. They want to know the maximum height of the ball, Okay, that's going to be the vertex of that parabola, and then they want to know how many seconds it's going to take until that hits the ground. All right, so there's a number of ways to solve this. The easiest way is just simply to graph it. Okay, so I'll go to Desmos, bring up the graphing calculator here. I'll go ahead and put this equation in. I'm going to use h of x, right, instead of t, but it works the same here. And so I've got negative 16x squared plus 96x plus 112. Oops, get that parenthesis there. Okay, and so I can see that. I'm going to zoom this out a little bit. Okay, and if I look at my graph here, right, I can see that that graph is a little hard to read. And so I'm going to make that a little bit easier to read. My x values looks like it goes from 0 to, around 250, 260. And then my x-axis looks like it goes between, 0 and, 10. Okay, so I'm going to go in here, and I'm going to change some of these settings here. Okay, and so this is going to be I'm going to go from 0 to 10 here, and for the y-axis, I'm going to go. I'm going to go from 0 to, let's go to 300. But I want to do it in steps of 50. Okay, so that makes that a little bit easier to see. All right. So in my picture here, this would be the top of the building. So if I click on that graph, I can see, right, the top of the building, right? So where the ball is released, it's 112 feet in the air. It goes up to a maximum height of 256 feet. And then it comes down and it hits the ground right here. And this is seconds, so this is going to be after 7 seconds. Okay. So I'm just going to go ahead and write these down on my paper here. So it's going to be the height here, right? So the vertex is at 256. And my x-intercept, right, or my 0, is going to be at 7, 0. Now, if I did this problem on, on Desmos and I wanted to submit that work, right, I would just simply do a screen capture of this, okay, on a Chromebook. I think it's what is it, like Control Shift and then the little video screen button. It looks like a little camera, a little icon that looks like this. So I think it's either Control Shift and that or Shift and that key, and then you can do a screen capture, and then you can just paste that into a Google document along with the rest of your work. Okay. All right. And that's how I would submit that work for there. You can also do it like this and draw a picture, and that works too. This point here I know is 7, 0. Right? This point here, right here where it's released is 0, 112. Right, is where it's released, and the vertex here is 3, 256. Okay, so let's go back to our problem. So we know that the maximum height of the ball was 256 feet, and then it took 7 seconds, right? It took 7 seconds for it to hit the ground. So 7 seconds here to hit the ground. And our last problem here is very similar to this, right? We've got a rocket that's launching. So here they give us this equation. So I'm going to go ahead and copy that equation just to save me a bit of time here. Okay, and so question number 13, again, if I can kind of draw a picture of what this represents, right? Negative 4.9 t squared plus 133t plus 213. Okay, h is height, t is time. The height is measured in meters, okay, meters above sea level. I can tell, right, I can tell that when this rocket launches, so here's the water, right, and here's some platform that it's being launched off of, right? This platform here, I can tell this platform is 213 meters tall. Right? I can tell that from the equation, right? If at time 0, right, that's my y-intercept is 213. And they want to know the same thing. They want to know how high that rocket goes, right? So what's the vertex? And they want to know here where it splashes down, right? How many seconds does that take before it splashes down? All right. So again, I'm going to go into Desmos and do that in here. I'm going to start a new equation here. I'm going to paste that in there. It doesn't paste perfectly, so when you do that, you have to kind of check. And again, they're using t. I need to use x here. Oops. Okay, so there's my graph there. You can see again, it's similar. I could change those values to make that graph a little easier to read, but that's not too bad right there. I can kind of see what's going on. So there's the height, right? There's where the rocket launches from. There's the top of it. Okay, so it reaches a height of 1,115.5 meters, and then it splashes down right after 28.6, 28.7 seconds. Okay, so I'm just going to go ahead and write these down on my paper here. So this is 13.5711115.5. My vertex here is going to be 0, 2, 13, or my starting point there, my y-intercept. My x-intercept here, where it splashes down, where my height is 0, 28.660. So go back here. The rocket splashes down after, and let's see, do they ask us to put in, okay, so they don't say how many decimal points to put in. So here I've got 1 decimal point, so I'm just going to put in 1 decimal point. So that's going to be 28.7 seconds. Okay. And the rocket peaks, right? So the maximum height is going to be 1,115.5 meters. Okay, so there is the practice test. So it looks like I got off in my problem numbering somewhere, but so that was the last one. I can see that we did pretty well on that. If you make mistakes, right, that's a good reason to have your work. You can go back and check that work and see what happened with it. And then if you were going to submit work, this would be perfectly acceptable to submit this work. Okay, on problems 1, 2, and 3, if I was submitting work, I would probably, maybe draw those graphs or something, or do a screen capture of them or something, and just, show those points. All right, I'll go ahead and end this here, and please let me know if you have any questions.